Alright, welcome to activity 35-1, surface area of pyramids and cones. This is Mr. Munyon here. Let's go ahead and get started on this lesson. So our goal in this lesson obviously is to practice finding the surface area of pyramids and cones. You may be a little bit familiar with these already, but we're definitely going to be practicing a little bit more with these, maybe given edge heights or different dimensions that we have to calculate some of the pieces to be able to find. So we are going to skip some of the story part of this one and mostly just get into the calculations. So first we need to make sure we know what a pyramid and a cone are. So hopefully you already recognize what prisms were. Prisms have two bases and all of the lateral surfaces are rectangles or parallelograms. Pyramids only have one base. It doesn't necessarily have to be at the bottom, but it has one base shape, and then all of the other lateral surfaces are triangles. So we see on these two examples, the base does happen to be at the bottom. We have a square here, and then all of the side or lateral surfaces are triangles. Same thing over here. We do have a base, if we think of the bottom as the base, and then all of the other surfaces are triangles. They don't have another base. They all just meet at a point on the opposite side of the base. So it says, consider a tetrahedron. Question number 1. A special type of pyramid with made up of equilateral triangles for the base and all of the sides. So let's suppose that one of the edges was 8 feet. That means all of the edges are 8 feet. Find the area of each face. Okay, so if I have a equilateral triangle, if I need the area, I need area equals 1/2 base times height for a triangle. The base is 8. And the height we could solve for using 30, 60, 90 triangles. If this is 8, this half is 4. So this is x, 2x, and x root 3, or 4 root 3. So the height is going to be 4 square root of 3. Okay, so 1/2 of 8 is 4. 4 times 4 is 16 root 3 for each face. Okay, from there, the next question says find the total surface area. So since there's 4 faces, I just multiply it by 4. And looks like we get 64 root 3. So I'm using total surface. Okay, so far so good. There is, just to be clear, there's one surface on the bottom and then there's 3 lateral or side surfaces on there. I do want to point out there is a formula you can use. Most students aren't going to memorize this, but if you want to find the area of an equilateral triangle, you can just take side squared root 3 over 4. That may actually save us some time in the future. So if we took 8 squared root 3 over 4, 64 over 4 is 16 root 3. We would have gotten the same answer here if we used that little shortcut formula as well. So side squared root 3 over 4 may help us here in just a moment. It says use the formula for calculating the area of an equilateral triangle to derive the formula for total surface area of the pyramids in terms of S. So notice right here, how do they get this value? Where do these come from? So if the area of one side is s squared root 3 over 4, and it has 4 sides, I could find the area of one of those equilateral triangles and multiply it by 4. The 4's cancel out, so the total surface area is just going to equal side squared root 3. And that is what we got as our answer. We do get 64 root 3. If the side was 8, 8 squared root 3 is 64 root 3 for the total surface area. So that's actually a somewhat convenient formula that you won't see on your formula chart. It's something you could add to your notes. If you wanted to find the total surface area of a regular tetrahedron, you could do that by just knowing one of the sides and plugging it into this formula. Okay, so it says the packaging engineer provided some materials. They provided a 27.75 yard sample of environmentally friendly material to cover a model of this tetrahedral shaped container. Find the dimensions. So let's say that this is the total surface area of the shape. So I know total surface area will equal whatever the side is squared times root 3. If I'm using this much total surface area, 27.75 equals side squared root 3, I should be able to divide by root 3 and then take the square root and solve for this one. So divide both sides by root 3. You get approximately 16.0, I don't even remember what it is, 4 something equals s squared. Take the square root of both sides, you get s equals approximately 4. So if you had a tetrahedron with exactly this much surface area, you could work backwards in this formula here and solve for s, the side length, or the dimensions of that tetrahedron. All right, let's use the formula from the formula charts. We're going to skip same thing, the story part of this one. We're actually going to use the formula from the formula chart. So down here, I went ahead and screenshotted what we need for pyramids and cones for the lateral and total surface area of pyramids and cones. And you'll notice the formulas look very similar. The only difference is for a pyramid, the lateral surface area and the total surface area, they added the base. So obviously the base added to the lateral surface will give you the total. Same thing over here. These are the lateral surfaces, and what's added, pi r squared, that's the area of one circle. That's the base of a cone, and this is the lateral part of them. So the formula for total really has the lateral part in it and the bases separately. All right, so we're going to be using these formulas. I'll just write them down when we need them. Back on our problem, it says consider the square pyramid. Suppose each side of the square base of the pyramid is 12 feet. So let's say we have a square base with 12 feet sides. And the length of each lateral edge is 10 feet. So the lateral edges are 10 feet. So this is an edge. This over here is an edge. Okay. Determine the perimeter of the base. That part's easy. The square has 4 sides. So 12 plus 12, 12, 12, or 12 times 4 is 48. How can you determine the height of a triangular face? So if I was looking at like this piece side here, it would make an isosceles triangle with a base of 12 and an edge height of 10. And I would need to figure out the height that's labeled as L on there to be able to figure out the base and height to figure out the area of this one. So if I cut this in half, each one of these is 6. Do Pythagorean theorem, 100 squared minus 36, 64, so 8 would be this side right here. So L will be representing the height of the triangles on the lateral surfaces, and that will end up being 8 feet on there. All right, so now that we have those pieces labeled, area of a triangle equals 1/2 base times height, or area of the triangles on the lateral surfaces equals 1/2. Each of the triangles has a base of 12 and a height of 8. So 1/2, 12 is 6 times 8. We do get 48. So each of these lateral surfaces is going to be 48. All right, the height of the triangular face is known as the slant height. So you'll notice here there are 2 different heights labeled on this shape. One is perpendicular in all directions to the base, whether you're going this way or this way or this way or back the other way. It's perpendicular, it's straight up. It's like a flagpole sticking out of the ground, it's straight up. That is the height of the pyramid, and that's perpendicular to the base of the pyramid. There's also a lateral or slant height labeled with L right there, and that is the height of the lateral surfaces. In this case, the lateral surfaces are triangles, so the lateral height will be the height of the triangles on the surface. And these are not the same value because notice if I was to draw a right triangle there, the lateral height would be the hypotenuse of a right triangle. It has to be longer than the legs, like H and whatever this piece is down here. So the lateral height will always be greater than than the height of a pyramid, and they're not the same values. It makes sense if we're finding the surface area, we need to use the height that's on the surface, the lateral height. If you're doing the volume is on the inside of the shape, we would use the height that's on the inside that's perpendicular to base. We would use h, the height, not L, the lateral height. So it says calculate the area of one of the triangular faces. Oh, I guess we already did that. All right. So let's, now that we kind of talked about the vocabulary, we know what a lateral height is, we know how to calculate it or figure it out in some cases. We also might need to use, if we were given like the height of the pyramid, we might need to use right triangles and Pythagorean theorem or something to be able to solve. So I'm sure we'll come across one of those. Let's now just get to practice with this formula. All right. So number 4, 5, and 6, we'll get some practice on 6. It says name the shapes on the lateral surfaces of a pyramid. All pyramids have triangles on the lateral surfaces. All right. Can a pyramid ever have quadrilaterals on the lateral faces? No. Rectangles or parallelograms, it would be a prism, not a pyramid. So no, that would create a prism. All right, number 6. Now we get to actually practice with this formula. Each side of the base of a square pyramid is 5. The slant height is 4. Let's calculate the lateral area, the total surface area, and then let's see, that's an interesting question as well. So let's look at this one first. So we have a square pyramid. Easiest way to draw a square pyramid is to draw the base kind of like a parallelogram. Find out where the center of that would be, go straight up, and then connect the dots to the vertices. All right, so here it says that the base of a square pyramid, each side of the base is 5 feet. So each one of these is 5 feet. The slant height of the pyramid is 4 feet. So let's make the slant height 4 feet. So the slant height is not the same thing as the edge height. The slant height is the height of the triangles, has to go through the middle of that isosceles triangle there on the side. The edge height would be one of the edges of the pyramid. So like this piece here is an edge, this over here is an edge, the one that we drew from that top vertex, all of those are edges. All right, so then the first question says calculate the lateral surface area. So in the formula for surface area of a pyramid, we have two parts. This is the lateral part, and this is the base part. And to find the total surface area, you just add those together. So let's first find the lateral, and then we'll find the base. So surface area equals 1/2. Capital P represents perimeter of the base. So 5 times 4 sides is 20. And the lateral height is given to us. We don't have to calculate it. Is 4. So 1/2 of 20 is 10. 10 times 4 is 40. The lateral surface area equals 40. All right. So this is the lateral surface area. If I want to add the base to that, the area of the base is a square. So base times height. So on this one, we would add 5 times 5. Or 25, and for a total we end up getting 65. So the total surface area of this one, part B, would be 65. Lateral surface area is 40 square feet, and total surface area is 65 square feet. Okay, next question says the slant height of the pyramid is doubled and the dimensions of the base remain the same to create a new pyramid. Describe how the change in dimension affects the lateral area of the pyramid. Okay, so let's say that I double the height. So the original one was 40. What happens if I double this to an 8? So instead of 1/2 20 times the lateral height of 4. What if I doubled it to a lateral height of 8? What's going to happen there? So 1/2 of 20 is 10. 10 times 8 is 80. The area would double as well. So describe how the change in dimension affects the lateral area. The lateral area doubles. Let's do another problem. We'll start with the formula and then plug in pieces. We might be able to use that shortcut that we had for the last one. Okay, for number 7, we have a regular tetrahedron. We're using the edge. We could use this formula here, but we're going to get more practice with it. Let's see if we can't use that shortcut formula that we came up with here that says the total surface area is just going to be side squared root 3. Well, let's do that one first. Side squared root 3. So 144 root 3 inches squared. So that is 4 total faces on a regular tetrahedron. So if you have your base shape here and you have your 3 sides, each of those should be the exact same area, 4 total. So if you wanted to find the lateral area, you could just divide this by 4 and figure out how much one face was and subtract it from that. So if I do that, we get 72 or 36 is one. So each face is 36. So subtract that, and we end up getting, what is that, 108. So lateral, oops, this was total, and then lateral would be 108. Root 3 inches squared. And you could obviously do this with the formula, but you would need to figure out the lateral height on this, and you need to figure out the area of the base anyway. So the shortcut formula did work faster on this one because it was a regular tetrahedron. So side squared root 3 is a convenient formula for total surface area of a regular tetrahedron. All right, for a cone, we can actually use the same formula. So I want to show you guys something here real quick and show how the formula for a pyramid relates to a cone. So for total surface area of a pyramid, we have 1/2 perimeter of the base times the lateral height plus area of the base. If we wanted to find surface area of a cone, we could do 1/2. The perimeter of the base would be the perimeter of a circle, so the circumference would be 2 pi r. The lateral height would be the same. It's the height up the side of the cone, so this would be like the lateral height, different from the height that goes through the middle. And then plus b, the area of the base. Well, the area of the base is a circle, so pi r squared. So the 1/2 and the 2 cancel out, and we end up getting the formula that's on the formula chart, pi rl plus pi r squared. So notice the formula that's on the formula chart for surface area of a cone is really just the same thing as the surface area of a pyramid, just written with the perimeter being the circumference of a circle, and area of the base is area of a circle, pi r squared. So if you didn't have the formula chart, but you knew one of these, you'd be able to figure out the other one. So let's jump down to some questions where we actually need to solve these and make sure that we need to do this. The book works through a lot of like showing where this formula comes from. We don't need to do that. We just need to practice using it. So let's jump down to the check your understanding. Compare the formula as well. We actually just did number 10 for surface area of pyramid and a cone. We already did that. All right, number 11. The diameter of the base of a cone is 10 centimeters. So the total diameter is 10, which means the radius is going to equal 5. If the diameter is 10, the radius will equal 5. The slant height is 7 centimeters. Okay, determine the lateral area of the cone and the surface area. So the lateral is just pi rl plus pi r squared. So all we need to do is plug in the radius and the lateral. So when we do that, we get pi times the radius is 5, and the lateral height is 7. So we get 35 pi, what is this, centimeters squared. And then for here, we need to plug in the radius for the base as well. So for total surface area equals pi 5, 7 plus pi 5 squared. So we get 35 pi plus 25 pi equals, what is that, 50, 60 pi? Yep. And these are the exact answers in terms of pi. You could plug in your calculator 35 times pi and whatever you get, like about 106 or 7 or something. I don't know, somewhere around there for the lateral. And same thing here, about 184, 185, somewhere around there when you plug that in with pi. All right, let's look at number 12. A plastic cone-shaped package is 10 inches in diameter and 12 inches high. Make a sketch, find the lateral and total. Okay, same thing, just different dimensions. All right, so the 10-inch diameter. So once again, we have 10 inches here. The radius would equal 5 inches. And it says that the 12 inches high, so that doesn't say the lateral height is 12 inches. It says 12 inches high, so that would be the height that goes through the middle. So we would actually need to solve for the lateral using a right triangle here to find L. And we can do that using Pythagorean theorem. So a squared plus b squared equals c squared. So 5 squared is 25, 12 squared is 144. We get square root of 169, or L equals 13. So the lateral height there is 13. I now have enough that I should be able to find the lateral height and, the lateral area and the total surface area. So the lateral surface area equals pi r L. Total surface area equals whatever we got for there, pi r L plus pi r squared. So let's go ahead and plug in our pieces again. All right, so 65 pi inches squared. So this is going to equal 65 pi. And then when we plug in the radius down here, we get 25 pi. So 90 pi for the total surface area. All right, so the lateral was 65 pi inches squared and total was 90 pi inches squared. Okay, so far so good. All we need to do is write down the formula, see if we needed to solve for any of the pieces. We did need to solve for the lateral on that one, then plug it in and simplify. For number 13, it says describe a step-by-step method you can use to find the height of a cone if you know the lateral area and the base area. Basically plug in the pieces you know and do algebra. Oh, okay, well let's do that. For number 13, let's go ahead and try it. So it says use your method to find the height of a right cone whose lateral area, so lateral surface area equals 136 pi, and base area equals 64 pi. So looks like we can start with the formula, plug in what we do know, and see if we can solve for the height. Total surface area equals pi r L plus pi r squared. If I wanted to plug in here, I know that this is the lateral and this is the base area, so I could plug in total surface area, equals 136 pi plus 64 pi But an easier way to do this one would be to use just this part to solve for r. Once I know r, I could plug it in here and then solve for L. And once I know L, I'll know the pieces of a right triangle I can use to solve for H. So since I know this equation is what I use to get this value, let's first solve for r. So I know that pi r squared equals 64 pi. So the pi's cancel out, take the square root of both sides. I get r equals only positive 8 because I can't have a radius that's negative on there, and we're using feet. So the radius equals 8. Now that I know the radius is 8, I can plug that in there. So I know that pi times 8 times L has to equal 136 pi. The pi's cancel out, divide by 8. And we get L equals 17. So now that I know the lateral height, I'm going to draw a picture here and see if I can't use the pieces that I just learned, the radius and the lateral height, to help me figure this one out. So I'll scoot this down just a little bit more. All right, so I have a cone. I figured out the radius was 8. I figured out the lateral height was 17, and to find the height, I just need to do Pythagorean theorem. So this will be the height here. So, and the hypotenuse is 17 squared. So what do we get here? 225? Oh, that's convenient. So 15 is our answer, which equals square root of 225 or 15. All right, so the height would end up equaling 15. And if you weren't sure if you did this correct, because it did take about 4 steps to solve for this one, you could definitely plug it back into the original formula. Make sure that you do get the lateral surface area and the base area that you're supposed to. Obviously the base is right, 8, or pi r squared. 8 squared is 64 times pi. You get 64 pi. Plug it in for the lateral surface area and make sure that's what you get as well. Oh, well, I guess just the Pythagorean theorem is the best way because the lateral height does equal 17. All right, let's try the lesson practice. I would suggest you try some of these on your own. So pause here, and when you start it back up, I'll have the answers for you. All right, so here are the answers. I did want to talk about 16 and 18. So you're welcome to screenshot some of these and make sure you know the steps. On 16, it says calculate the surface area of the cylindrical rocket and nose cone if the slant height of the nose cone is 8 feet. So on this one, it's a composite surface area. You have to know which pieces you can and can't use for the surface area. So if you were doing them individually, you just do the total surface area of the cylinder and the total surface area of the cone. However, when you put the cone on top of the cylinder, 2 of the bases disappear. They're not part of the surface anymore. So you'd have to get rid of them. So what you could do is you could think of this base at the end of the cylinder as the base of the cone and find the total surface area of the cone, and then you don't need either of the bases on the cylinder because the one that is part of the actual surface we can think of as the exact same circle. That would be the base of the cone, and that's the only circular surface that you could see. So find the total surface area of the cone, which I did right here. And then just the lateral surface area of the cylinder. So that's where I got these formulas from. And then you can see here where I plugged in the pieces. So if you need to screenshot there, you can. Here's my work for number 17 as well. Zoom in just a little bit. You can screenshot if you can. And then number 18 was the same thing with a cone on top of a cylinder, trying to find the total surface area. You did need to make sure you labeled correctly. It didn't give you the lateral height on this one, so when it gave you the height of the cone, we did need to solve for that lateral height to get the surface area. But you ended up having to do the same thing, only use one circular base for the area. So I did the total surface area of the cone and then just the lateral surface area of the cylinder again. All right, if you need more practice, there's lots of good practice on Khan Academy. Surface area of pyramids and cones are two different exercises. It's exactly like this type of stuff. Really good practice there, so you'll know if you're doing them correctly or not, and you can become more efficient at them, so you can do them much faster. All right, see you guys on the next lesson.